Its jaws are cutting off 40 honeybee heads in just 60 seconds. It is a giant hornet with a stinger that melts cells from the inside. Their danger level is so high that they take more human lives in Japan than all wild animals combined. Any animal that smells them has to run away. Except for one bird. It flies straight through the angry swarm, charging directly into the nest. Despite thousands of deadly venomous stingers stabbing into its body again and again, the bird calmly digs through the nest and eats all the larvae with incredible ease, without showing even the slightest sign of pain. What is this bird, and how does it survive this lethal attack? The creature spreading terror is called Vespa mandarinia, the giant hornet. It is 4.5 centimeters long, with a wingspan of up to 7.5 centimeters. It is the largest hornet on Earth. It is not only huge, its body structure is perfectly programmed for one single purpose: attacking other colonies. Its venom is completely different. The toxins immediately destroy tissue around the sting wound, the compounds trigger instant swelling, and a series of protein chains amplify pain beyond the normal tolerance threshold of the human nervous system. Survivors describe the feeling as if a red-hot iron rod had been driven through their flesh for many hours. In only 45 seconds, a stung hand can become completely paralyzed. The pain lasts for a day and a half. But the venom is not the worst part. The way they hunt is the real nightmare. They do not hunt alone. When one scout finds a honeybee colony, it leaves a scent mark at the entrance. A few minutes later, an army of 15 to 30 giant hornets arrives. The slaughter phase begins. No defense, no mercy. 40 decapitations every minute. A colony of 30,000 honeybees can be completely defeated in only 90 minutes. After clearing out all life, they calmly occupy the nest and collect all the larvae inside to feed their next generation. Asian honeybees have lived alongside this species for millions of years. They have a counterattack. When attacked, 500 worker bees immediately wrap around the invader into a living ball. They vibrate their wing muscles continuously to raise the temperature inside the core to 46 degrees Celsius for 30 minutes, cooking the hornet alive. The tolerance limit of the honeybees themselves is 48 degrees Celsius. They accept standing just 2 degrees Celsius away from death to protect their nest. However, Western honeybees, the foundation of the global pollination agriculture industry worth tens of billions of dollars, do not have that ability. Evolution has never forced them to face this predator. Against the giant hornet, they can only wait to die. That is why, when this hornet appeared near the northern border of the United States in late 2019, an unprecedented panic broke out. If this predator reproduced widely, honeybee populations would decline severely, leading to the collapse of a massive agricultural ecosystem. But humans did not sit still. A large-scale hunt was activated in a way so strange that no one could have imagined it. The Washington State Department of Agriculture faced an impossible problem, finding a nest hidden deep inside a dense forest, covering thousands of hectares. They came up with a plan. Step 1. Use bottle traps containing orange juice and rice wine to capture live scout hornets. Step 2. Attach tiny radio tracking devices to their backs. The problem was that the device was slippery and could not be attached with ordinary glue. Experts had to use the cheapest thing available, dental floss. They tied the device onto the back of the giant hornet and released it, hoping it would fly straight back to the nest. Things did not go smoothly at all. The first hornet died as soon as it took off. The second one bit through the dental floss, leaving the tracker behind in the forest. The third one was completely exhausted. The research team had to feed it strawberry jam to restore its energy. When the hornet regained strength and took off, the entire team carrying radio antennas quickly moved through the forest. The signal led them to a rotten tree hollow. For the first time in history, a giant hornet nest was destroyed on American territory. Over the next 12 months, they spent nearly $1 million more just to deal with only 3 other nests. An expensive victory. The United States succeeded only because it detected the problem early and contained it within a narrow area. Look at Europe, where everything has already gone out of control. The yellow-legged hornet, a smaller relative, invaded France in 2004 from just one queen hiding inside a shipment of ceramics. Now, they have spread across Spain, Italy, Germany, and Britain. Losses have reached up to 30% of total honeybee colonies in many countries. The cost of fighting back has reached €12 million each year. Trapping is ineffective. Spraying chemicals does not work. When all human technology becomes helpless, people begin to wonder, does the natural world have any control mechanism? The answer has always been there. It has been flying above the treetops of Asia for millions of years. Let me introduce you to the Oriental honey buzzard. It is about 60 centimeters long, weighs less than 1.5 kilograms, and is much smaller than most eagles or hawks. Its face looks more like that of a friendly pigeon than a top predator. Its English name contains the word honey, but it does not eat honey. What it targets is larvae, the pure concentrated source of protein and fat hidden deep inside hornet nests. It does not hunt with muscle power. It hunts with memory. This bird circles at an invisible height, tracking the flight paths of scout hornets. It remembers the nest location, calculates the timing, and sometimes waits for many days until the nest is least defended. Then it dives down without a sound, using its beak and talons to break open the nest shell, which is as hard as concrete, takes the larvae, and flies away. It has extraordinary spatial memory that allows it to return to that exact location the next day. But, as soon as a hole opens in the nest, a violent counterattack begins. Thousands of hornets rush out from all directions in a state of agitation. In less than 30 seconds, the giant swarm surrounds the bird. Hundreds of stingers filled with dangerous venom stab straight into its feathers. At that moment, the scene looks like a fortified fortress calmly eating lunch in the middle of a rain of poisoned arrows. The bird does not run away. There is no sign of pain. It does not slow down when taking off. Why does it not die? The secret lies in a 5-layer structural armor that evolution has spent 50 million years perfecting. Layer 1: feathers. Scientists placed this bird's feathers under a microscope and compared them with those of other predators. The result was astonishing. The feathers on its head and neck are extremely short, stiff, and layered over one another like smooth fish scales. Tiny microhooks lock the feather fibers tightly together, forming a perfect physical barrier that makes hornet stingers slide off instead of piercing through. Beneath that scale-like layer is unusually thick skin, acting like a shock-absorbing cushion that absorbs the force of the sting. Layer 2. The eyes. The only weak point of every creature is the eyes. So why does the swarm not attack there? Because they are not fast enough. The bird's eyes are equipped with a semi-transparent membrane. This shield flashes sideways across the eyeball in an instant, completely protecting the eyes from incoming stingers while still allowing the bird to see everything around it clearly. Layer 3: anchor legs. Its legs are not used to snatch prey like an eagle's. Their straight structure and deeply gripping talons act like anchors, helping it stand firmly on vertical surfaces even when thousands of hornets slam into it from every direction. Layer 4: chemical interference. Recently, scientists discovered that this bird releases a special scent. This scent can disrupt the hornet's pheromone recognition system. Hornets normally communicate through scent to coordinate attacks. But when they smell the bird, they become disoriented, their formation breaks down, and those life-or-death seconds allow the bird to gather enough larvae. Layer 5: disguise. It looks exactly like a very aggressive ordinary hawk. This mimicry helps it avoid being attacked by larger predators while it is focused on breaking into hornet nests. 5 layers of absolute defense. A body optimized without a single wrong detail. But what is even more astonishing is how this creature behaves when facing an ecological crisis in Europe. When Asian hornets invaded Spain and France, the ecosystems there became paralyzed. But ecologists discovered an unbelievable change in the statistical data. In areas invaded by hornets, the reproduction rate of the native honey buzzard, a relative of the Asian honey buzzard, surged by 300%. Nesting success reached 100%. On average, Each bird pair destroyed between 30 and 60 invasive hornet nests in a single breeding season. The harmful hornets suddenly became the richest nutritional food source, helping the birds multiply at a shocking speed. They do not passively sit and wait for food to fly by. When the invasive hornet reaches a new land, the migrating birds follow its traces. Nature is rebalancing the scales by itself. The most reasonable question now appears: if this bird is so effective, why does the United States not import it to protect an agricultural industry worth billions of dollars? Because the world once learned an expensive ecological lesson. Introducing a predator from one continent to another to control pests rarely leads to a happy ending. A typical example is the cane toad disaster in Australia. They were brought in to eat beetles on sugarcane. But they ignored the beetles and ate everything from native animals to domestic pets, becoming a serious ecological imbalance disaster. The honey buzzard is no exception. It does not only eat wasps and hornets, it eats frogs, lizards, and even other small birds. Moreover, with its constant migratory habit, nothing guarantees that it will stay where the hornets are. Instead of forcing the bird to work for us, humans are beginning to learn from its design. Studying the scale-like structure of its feathers to create ultra-light protective materials that cannot be pierced, analyzing the bird's scent to produce hornet-repelling compounds that do not pollute the environment. That is the future of biomimicry. And the truth is, the United States no longer needs the presence of this bird, because the story of the giant hornet has just ended in a way no one expected. However, behind that victory lies a much darker truth. As of 2026, agricultural agencies in the United States have confirmed the giant hornet has been completely controlled on the territory after years of close monitoring. Banners were raised, but if you look at the latest report on the honeybee industry over the recent period, the actual data shows a far less optimistic picture. The loss rate of honeybee colonies in the United States reached 55.6%, the highest record of all time. 1.6 million bee colonies disappeared without a trace in just 12 months, pushing more than $17 billion of the pollination agriculture industry to the brink of collapse. It is worse than the large-scale crises that occurred during the 2000s. The giant hornet has been completely eliminated in the United States. So why are honeybees still declining so severely? Because the appearance of the hornet was only a surface-level event, one that easily attracted attention. Meanwhile, the main factors causing honeybee populations to decline continue to unfold: sudden temperature changes caused by climate change, disrupting flower blooming cycles, the spread of parasitic mites, and industrial chemical residues accumulating in farmland soil every year. Humans panic at the jaws that can kill 40 bees per minute, but they turn a blind eye to chemical-contaminated fields that make 1.6 million bee colonies disappear each year. Deep in tropical forests, the law of survival has never belonged to the biggest, the loudest, or the most terrifying. That small bird is facing its own challenge. The disappearance of wild bee and wasp colonies due to human impact is exhausting the bird's food source, leaving young birds malnourished. It is classified as least concern because its numbers are still large. But that is a trap. When the quietest creatures disappear, the natural balance will collapse before we realize it. The existence of the honey buzzard shows this in the biological world. The most effective survival mechanisms often come from special adaptations developed over time. Humans can spend millions of dollars, mobilize many resources, use radar waves, and set up smart traps just to handle a few insect nests. But ecosystems developed effective balancing measures tens of millions of years ago through optimized biological traits. Instead of prioritizing artificial interventions to change the environment, studying and applying natural laws may bring more sustainable solutions. In the area where you live, have you ever noticed any changes caused by alien species affecting the surrounding environment? Between using scientific intervention methods and allowing the ecosystem to regulate itself, which approach would you prioritize? Share your story in the comment section.